Hello everyone and welcome to week 5. Congratulations, you've made it. You're almost there. A quick note, week 6 is a very short week and the schedule is different. So be sure to check that schedule so you can have all of your work turned in on time. There will be no late work accepted in week 6. So make sure you check that schedule after this week. Check week 6 schedule so you can have all of your work turned in a timely fashion. All right. Now this week we're going to look at percents, and we're going to look at how to convert from percents to decimals, decimals to percents, and we're also going to look at a few different word problems. Okay, so let's get started. All right, the first problem we have is converting a fraction to a percent. In order to convert a fraction into a percent, we first need to convert that fraction into a decimal number, and we've converted fractions into decimal numbers before. So to convert 17 over 3 into a decimal, you would simply divide. And to start dividing, 3 would go into 17 5 times, 5 times 3 is 15. Subtract. And remember that decimal comes straight up. And you'll bring this 0 down. 3 will go into 26 times. And then 6 times 3 is 18. Subtract. And you will bring the next 0 down. And 3 will go into 20 again 6 times. And as you can see, we're going to end up with a repeating pattern. So we know it's going to be another 6 out there. Let's say that that's about 5.67. So let's round it to the hundreds place there. Now we've converted it to a decimal, but to finish it off, we have to convert it to a percent. We have to take that decimal number and multiply by 100. Whatever the decimal number is, we have to take that decimal number and multiply by 100. So I'm going to take 5.67, multiply it by 100, and that will give me 567%, which will be my answer. So you need to convert your fraction to a decimal first, and then take that decimal answer and multiply it by 100. Now you're going to see a whole lot of multiplying by 100 and dividing by 100. Percent means per 100, so that's why we'll use that 100 so much with these problems. Okay, so this one's a little bit easier because it's already in decimal form. We want to convert 0.34 to a percent. All we have to do is take that decimal number and multiply it by 100. So 0.34 is the same as 34%. So you convert a decimal to a percent by multiplying by 100. If we have a percent that we want to convert back to a decimal, we would simply divide by 100. As with this one. We have 7.85%, and we want to convert that back to a regular decimal number. So to do that, all we have to do is to divide by 100. And when we divide by 100, we get 0.0785. And that's all there is to it. To convert a percent back to a regular number, you just divide by 100. Okay. Let's have a look at this problem. It says an oil tank is 30% full. The capacity of the tank is 315 liters. what is the volume of the oil in the tank? We have a formula for percents. It says A, which represents amount, equals the percent over 100 times the base. Now the base represents the total amount possible. Uh, the amount represents a partial amount. So the base, or B, represents the total amount possible. So if I want to work this problem out, we have an oil tank that is 30% full. So that means that's my percent number. The capacity of the tank, the total amount possible for it to hold, is 315 liters. So that would represent my base. Now we're looking for what is the volume of the oil that is in the tank right now at 30% full. So we're looking for A, or the amount. So I'm going to set up my equation. Percent over 100, so 30 over 100, and we place that over 100 so we can convert that to a regular decimal number. Remember how we divided by 100 to convert a percent to a decimal? That's why we place 30 over 100 to convert it into a regular decimal number, times the base, which is 315 liters. 315 liters. So first of all, let's do our division using 30 divided by 100. And then that gives us 0.30 times 315. And then when I multiply that, I should get 94.5 liters. So the amount that's in the tank when it's 30% full is 94.5 liters. So we used this equation because we were trying to find the amount, and this equation can be rearranged in different ways, as I'm sure that you saw in your online lectures. So we'll look at a few different ways that it can be rearranged to find different things. Okay. All right. Let's have a look at this one. It says John traveled a total of 900 kilometers, or kilometers, however you like to pronounce it. He covered 65% by plane and the remaining distance by train. How many kilometers or kilometers did he cover by each mode of travel? So he traveled a total of 900 kilometers. So that would represent my base. That would represent the base because that's the total. He covered 65% by plane, which means that he had to cover the other 35% by train. With the information given, let's find out the amount that he covered by plane. And we're going to use the same formula that we just used. The amount equals the percent over 100, so 65 over 100. And again, we place it over 100 because we want to convert that into a regular number, times the base. And in this case, the base is 900. Now this is going to give us the amount that he traveled by plane. So let's see what we come up with. Divide that, we get 0.65 times 900. And then we're going to multiply 0.65 times 900. And we come up with 585 kilometers by plane. Now our question asks for the amount he traveled by plane and by train. So we have one part of our answer, 585 kilometers by plane. So if we know he traveled a total of 900 miles, and then we just found that he traveled 585 of those, I'm sorry, not miles, kilometers. He traveled 585 kilometers by plane, then I can subtract to find out how much he traveled by train. And that gives me 315. So that will give me a total of the 900 kilometers. So again, we found out the amount he traveled by plane, and then we just subtracted the total amount minus the amount he traveled by plane to see what was left for him to travel by train. And that gave us our two distances. But again, we use the same, we use a percent formula in the same form. Okay. All right. Jennifer spends 2 hours every day practicing basketball. She sleeps 6 hours a day. What percent of hours does she spend on practicing basketball for the rest of the day? Okay. So we know there are a total of 24 hours in a day. So if she sleeps 6 hours, then the time she would have available to practice would be 18 hours. The total amount of time that she has available will be 18 hours. That's the total she has to practice. So let's see here. We said she spends 2 hours every day practicing. So let's change this. This is wrong here. The amount that she spends practicing is 2 hours. So that should have been a 2. All right, so amount is 2 hours. The base, which is the total amount available for practice, is 18 hours. So let's find the percent. So we're going to rearrange our percent equation first. And we're going to have percent equals amount over base times 100. Okay. Okay, so we have 2 divided by 18, which gives us 0.11, about 0.11, and again we'll round to the nearest hundredth. And we're going to multiply that by 100 to change it into a percent. And that should give us about 11%. So that tells us she spends about 11% of her available hours practicing basketball. Okay. All right. A store sells bikes for $73 per bike. If each bike costs the store $49, how much profit percent does the store earn? Profit percent, and another way that this can be phrased is percent increase. So what we do first is find the profit, or we get the difference of the two prices. So we have what the cost of it, or what the bike is going to sell for, minus the cost of the bike, and that's going to give us $24. So we'll start off, we're going to use the equation profit percent or percent increase equals the profit over the cost price times 100. So the profit was $24. The cost price is what it costs the seller. How much did the seller actually pay for the bike? So in this case, the store bought the bike for $49, but they sold it for $73. So here's the profit over the cost times 100. So 24 divided by 49 gives us about 0.49. Again, I round it to the nearest hundredth. Then we're going to take the 0.49 and multiply it times 100. And that tells us that the store's profit percent was about 49%. About a 49% profit. So again, we use this equation. The profit over the cost price equals 100, and you find the profit by subtracting how much the store is selling the bike for versus what it costs them to purchase the bike. And the cost price represents how much the store actually paid for the item, in this case the bike. Okay, a bookstore gives a 15% discount on a new book. If it makes an 18% profit, then what percent does the mark price exceed the cost price? Okay, so again, the cost price is what it actually costs the store. The mark price is what it's actually marked for. So let's look at what we have here. We have to give this item, this book, which looks to be an expensive book, but we have to give it a price. We have to give the book a price. And I always give the price when I'm dealing with percents of 100, because when we deal with 100%, then the costs and the percents will match up if you start off with the base of 100. So I'm going to give the cost price of the book $100. And I'm going to let the mark price equal M. I'm going to let it equal the variable M. So what we know is if the store made an 18% profit, if it costs the store $100, if it makes an 18% profit, then 18% on the $100 would mean the selling price is $118. So again, they made an 18% profit on the $100, so that means that the selling price had to be $118. Now what we also know is that the store gave a 15% discount. So if they gave a 15% discount, and you have to think in terms of 100%, if they gave a 15% discount, then the buyer paid 85% of the marked price. They got a 15% discount, so the buyer paid 85% of the marked price. So the selling price, which was $118, had to equal 85% of whatever the original marked price was. So let's work this out. And we know the selling price, we just said that the selling price is $118 because they made an 18% profit. And they got a 15% discount, so they paid 85%. And let's change that to a regular number, 0.85 times the marked price. And we don't know what the marked price is. That's what we're going to find out now. Okay, so we're going to undo this equation and solve this for M. So I have 0.85 times M. To undo that, we need to divide by 0.85, like we learned in week 4. So if I divide 118 divided by 0.85, we come up with $138 and about 82 cents. So the marked price was $138.82. That's what the tag had on it, $138.82. All right, now our question asks, what percent does the mark price exceed the cost price? Well, if the mark price was $138.82 and the cost price was $100, since I use 100 and 100 is the same thing as 100%, then all I have to do is subtract the two prices, and that would tell me the percent that the mark price exceeded the cost price. which would be 38.32%. The marked price exceeded the cost price by 38.32%. So again, you have to be careful with these terms. Cost price means what the bookstore actually paid for the item. Marked price is the original price on the tag, and the selling price is the discount here. So it said, let's walk back through it. It says that the store made an 18% profit. So if the cost price was $100 and they made an 18% profit, 18% profit on $100 would be will give a total of $118, because 18% of $100 is $18. So that would make the total of $118. So we also know that the selling price, the price the item was on sale, is equal to 85% of the original price. And it's 85% of the original price because there was a 15% discount. So they paid 85% of the original price. So we used that equation to figure out what the marked price was, which is we had to divide. First of all, change 85% to a decimal number, which is 0.85, and then we had to divide. So that gave us $138.82. So to find out the price, what the exceeded was, we just subtracted $138.32. That should have been 82 cents, I believe. Should have been, sorry about that. 82 cents, and subtract minus 100, and you get 38.82%. Okay? All right, let's look at this one. It says a ball dropped from a certain height. It rises 18% of the original height after bouncing. The ball rises 5 feet after bouncing. What was the original height? So the original height would be the base. It'll be the total height that the ball was dropped from. We know that it bounced after it hit the ground. It bounced and rose 5 feet of the original height, which was 18% of the original height. So we have the percent, we have the amount, which is the partial, and then we want to find the base. We want to find the whole height, the entire height, the original height from where the ball was dropped. So again, I've rearranged our percent equation, and if we want to find the base, then we would need to divide the amount divided by the percent, and then we'll multiply it by 100, and we do that to change it into a regular number. So we have 5 divided by 18 equals, that gives us about 0.28 if we round it. And if we multiply that by 100, that tells us that the original height was about 28 feet. The original height was about 28 feet. So that's the equation that we use, or the form of the equation that we use when we want to find the base. Okay. All right, let's look at this one. It says, what single discount is equivalent to 2 successive 15% and 8% discounts? Sometimes when you go in stores, they'll give you a 25% discount, and then they'll tell you that you'll get an additional 7 or 8% discount. So you really, if you get a 20% discount and they tell you that you get an additional 8% discount, you really don't get a total of 28% discount. So let's see how this works. Again, I'm going to use 100 because we think of percents as total base as being 100. So if we use $100, it kind of matches up with the percents. So let's start off with the original cost of an item of $100. And let's find out what we'll pay for the item if we get a 15% discount. So if we get a 15% discount, that really means we're paying 85% of the price, or 85% of 100. So to find that, remember, let's go ahead and just change the 85% into a regular number, 0.85, and multiply it times 100. And that'll tell us the price that we're paying when we get that 15% discount. And 85% of 100, or 0.85 times 100, would give us $85. So the original 15% discount puts us at $85, but we're going to get another discount on top of that, but it's going to be on the $85. So now we're going to get an 8% discount. And with that 8% discount, if we get an 8% discount, then we're really paying 92% of the price. And now our price is at $85 because we just had a 15% discount. So now our price is at $85. We're going to get a 92% discount off of the $85. So let's find 92%. I'm sorry, we're going to get an 8% discount off of the $85. So let's find 92% of the $85. Again, because if you get an 8% discount, then you're paying 92% of the price. So with that discount, now the price is at $78.20. So our question was, what was the total percent discount that we got? Well, if we started off with the base of 100 and then we ended up at 78.20, then that means that we got a actual discount, total discount of 21.8%. Okay, so you don't get that full 23% as what many would think, because you have to take the first discount first, and then you get a discount off of that price, and that's why we wouldn't have a total of 23% discount. Okay, all right. A CD costs $9.50. If the sales tax rate is 8%, how much tax is charged and what is the final price? Well, we can find the tax amount by multiplying the cost by the tax rate, and it's 8%. So I'm going to go ahead and change that 8% into a regular number. 0.08, and remember, we change a percent into a regular number by dividing by 100. Now after that, I would multiply those two numbers, 950 times 0.08, and that would give me the amount that I would be paying in tax. So 0.76 is the tax amount. So that's part of my answer. The second part said, what is the final price? So the final price, or the total price, would be the original $9.50 plus the 76 cents in tax that we're paying, which would give us a total of $10.26. So we find the tax on the amount, and then we just add that dollar amount, that tax amount, to the original price to give us our final price. Okay, let's take a look at this last problem here. It says John earned $500 last week and $750 this week. What is the percent of increase for his pay? Now this is the same equation that we use for profit percent. That's the same equation. It has some different words in there, but that's the same equation that we use for profit percent. So we're going to get the difference of the pay, and it's always the big number minus a small number when you get the difference of pay, over the original number. So his original pay was 500. And then to convert that into a percent, we'll multiply it by 100. So again, get the difference in between the two amounts, the difference in between the pay, and it's always big minus small, not necessarily new minus original, but it's always big minus small over the original pay times 100. All right, so when we subtract that, we get 250 over 500. And then if we divide 250 divided by 500, that gives us 0.5 times 100. And 0.5 times 100, to change it into a percent, would be 50%. So he had a 50% increase in pay. So again, I have new minus original, but it's always the big number minus a small number up here, because you would not want a negative up here. So it's always a big number minus a small number up top. All right. So that's a lot for you to digest for this week, dealing with percents. Make sure you go through the online lectures and the examples in the textbook, and view any recommended videos that you may find in the announcement area. And you may want to view this a couple of times. And I wish you well this week. And again, we're almost done, so I want you all to hang in there. And remember that week 6 is a very short week, and the schedule is different from the other weeks. So be sure to check that schedule to get all of your work turned in on time. And no late work will be accepted in week 6. So make sure you check out that schedule. All right. You all have a good week 5.